Today we're going to find permutations and combinations. The first thing we need to define before we can look at those is a factorial. And a factorial is the product of all positive integers up to and including a particular number. And to represent factorial, we use an exclamation point. So it looks like this. This says read 6 factorial. And by our definition, we would take 6 times 5 times 4 times 3 times 2 times 1, because those are all the positive numbers up to and including our particular number. Multiply all those together. 6 factorial is equal to 720. Okay, we can use factorials in a little different way. We might have multiple factorials inside of a fraction. So 10 factorial over 2 factorial times 10 minus 2 factorial. We still are going to use order of operations here, so we'll simplify our parentheses first, and then we can go ahead and simplify. Now, we know that factorial means that we multiply every number below our particular number. And so I'm going to rewrite our 10 factorial in a different way. We know 10 factorial is technically 10 times 9 times 8 times 7, and so on. I'm going to write it as 10 times 9 times 8 factorial. This is the exact same as 10 factorial. It just is rewritten in a different way, in an equivalent way, I should say. I wrote it that way so that now I can cancel off my 8 factorial on the top and my 8 factorial on the denominator. That leaves us with 10 times 9 over 2 factorial. And this is now a problem we can do in our head. So we have 90 over 2, which simplifies to be 45. So between our first step and our second step, those are equivalent statements. We just wrote it in a way that could be simplified a lot easier. That leads us to our definition of what a permutation is. A permutation is when you're going to select different items, but the order that you select them matters. It has a formula. So a lot of times it will be P and then parentheses N comma R. We say we have N objects chosen R at a time, but then here's our formula. So N factorial over N minus R factorial. An example, the permutation of 6 items taken 3 at a time. Our 6 is our total number of objects, so that's the N value, chosen 3 at a time, so that means 3 is our value. If you plug those in, we have 6 factorial over 3 factorial. And again, I rewrote this just like I did our other example. 6 factorial is 6 times 5 times 4 times 3 factorial. We can cancel those 3's off, and we have 6 times 5 times 4, which is 120. I'd like you guys to find the permutation of 7 objects chosen 5 at a time. Okay, combination is the other one, very similar to a permutation. This time when we choose our items, the order does not matter. A very similar formula, and an R still stand for the same thing. This time we have a little r factorial in the denominator as well. So an example, a combination of 5 objects taken 2 at a time would be C 5 comma 2. Here is plugging our numbers into our formula. That simplifies to be 5 factorial over 2 factorial, 3 factorial. If you rewrite 5 factorial like so, you can cross off your 3 factorials and you get 20 over 2 factorial. Well, 2 factorial is just 2, so that simplifies to be 10. So you guys can find the combination of 7 items chosen 4 at a time. We're going to look at kind of a word example. If we are trying to make pizzas and we have 2 types of crust, say they're like thick and thin crust, and then we have 3 different toppings, but we are only allowed to choose 2 toppings, we have to decide how many different pizzas could we actually create. So we want to start with our first option. So we have to make a choice between our crusts. So we would have a combination of 2 items, 2 choices chosen one at a time, right? Because we can't have both thin and thick crusts at the same time. And then we have to look at our toppings. Well, we know we have 3 options and we only choose 2. So we go ahead and evaluate both of those, and we're going to multiply them together because it goes back to our fundamental counting principle from the other day. So I plugged all our numbers in. This fraction, our crust options factor down to 2 options, and our toppings simplify to 3. So we have a total of 6 different pizzas that we could create. Okay, Wondering about how many two-letter arrangements can be formed from the letters C, A, and T. Well, when we're talking about letter arrangements, we have to note that CA different than AC. They use the same letters, but the order does matter. Um, Deciding that our order matters tells us that we have a permutation. So we take our permutation of 3 objects, chosen 2 at a time, because we have 3 letters to choose from. We're only choosing 2 of them. Plug our numbers in, and we would have 6 different options or letter arrangements that we could create. I want you guys to answer this question. How many two-man crews can be formed from these 3 men? I want you to first tell me whether it's a permutation or combination, and then actually tell me how many two-man crews can be formed.